Like, some people need to write down more, or like every single word that I write down. If you don't need it, you don't have to. I'm going to trust your judgment with it. I don't do note checks or anything like that. You guys are, 17 and 18-year-olds. I trust that you know how to do school. Here we are. Okay, so we're still in 4.4 and it's continuing on. This is what we talked about yesterday. So this is just a quick recall. Did you watch a video from yesterday? Super easy. Do you agree if I said, like, I'm just going to make up a number, 150 degrees. If I said make a triangle with a 150 degree angle, that's a weird triangle to make, right? So it turns out that instead of using 150 degrees, if this is the final or terminal side of my angle, my bow ties and butterflies say just deal with this triangle. By dropping straight down, this angle, theta apostrophe, I never want to hear that again, and I hate that I just said it. How do I read that angle, Fern? You weren't here. How do I read that angle, Fern? Theta prime. Okay, that same notation shows up in calc again next year, just so you guys are aware. I only drew one here, but you could do this at any part of an angle. So just as a quick recall, we had some rules on how do we do it, but if I wound up going all the way down to here, here's my theta prime. I'm just making that acute angle with bow ties and butterflies. That easy. Now, our task today, and you've already done a bit of it, which is pretty awesome. The only last section that we have is how do we actually evaluate trig functions using any angle theta? And one easy answer is these reference angles. So I will give you guys a second. When we're doing this, there's not many times in math when I can say, hey, do this, then this. But check this out. To do this, first do that, and that got weird. I had it worked out in my head. It didn't shake out that way. Step one, any angle theta that I give you, whether it's in radians or degrees, identify the quadrant that it's in. That's your first important part. And the only reason that we would do that is because when I find theta prime, it's essentially spinning everything to make it in quadrant 1 so that I don't have to memorize everything. It makes it easier. But your signs get goofy because as you move through your rotation, the signs change constantly throughout the circle. Okay, step 1, find the quadrant. Step 2, find theta prime. Use that, and then just give positive or negative based on where you're at. So, I'll give you guys a second because it's weird. I don't have to write it down. Here's a regular size sheet of paper. I left a lot of blank space for stuff. Show me yours again. Is it, I can't tell if is that writing true? No problem. Yeah. If they don't, I'm so sorry. Wow. Cool. So, step 1, determine which quadrant. Step 2, find theta prime. That's like the whole problem. Every time. In physics, we just kind of gloss over this and we just use the acute angle every time anyway, but this is the real formalization of that. Okay. Once you get steps 1 and 2, find quadrant, find theta prime, all we got to do is think about the unit circle. Or rather, how we measure angles on a coordinate plane is a better way to say that. It's really weird to not have to pause for writing, so I'm going to let you guys catch up with me for a minute. Charles is killing it. He writes like 40 words a minute. I have no idea if that's fast or slow with handwriting. I'm going to Google that here in a minute. Kalisha, can I get you to AirPod out? Was there stuff playing in it or no? Oh, okay. Just curious. All right. I no idea where you guys are time-wise. This part is just my... I assume that's yours because your AirPods just turned off. Oh, whoever it was, I don't care. Will you turn it, is it going to keep going? It must be one of you guys, right? I don't know. No idea. Never heard that in my life. I got you. I'll put it back in. Cool. So, when we're here, just what number were you? Okay, I couldn't remember where I took it. Was that Kendrick Lamar? Shot in the dark. All right. So, here is our 4 quadrants. Now, notice, remember there's that ugly word called quadrantal angles, which are 90, 180, 270, 360, that fall right in between. You couldn't say where they are. All I've done on this table, and as much of it as you need, as long as you know that this is a Cartesian plane where this is the origin, that's all I think you really need. All I've done is said, check it out. Between 0 and pi halves in radians, if we think about sine, cosine, and tangent, it can get confusing, but easier than that, let's just think about x's and y's. And I know that x's are cosines. In quadrant 1, no matter what ordered pair, is the x and the y always positive? So check it out. Positive, sine, cosine, tangent. And since sine is positive, if you flip it and get cosecant, it's positive still. So I'm only going to list these 3. What I want you guys to do is spend just a moment. I want you to fill out this table for me. If you need to get a unit circle, you can, but just think x's and y's. As long as you know x is cosine and y is sine, the rest of these are hopefully pretty quick. I'm going to pause it here, and I'm going to have you guys do that. Check with each other. I'll fill this out, but I'll give you a head start. Is everybody at that point at least? Okay, cool. I'm going to pause it. All right, so coming together here. Let's look right here first. Which quadrant are we in? Right here. That's quadrant 2. In quadrant 2, what's positive, the x or the y? The y values. And y is sine or cosine? So check it out. I know that sine is positive here. Are the x's positive or negative in quadrant 2? They're negative. So because x's are negative, cosines must also be negative since they just represent the x. Now, if you struggle with a tangent, let's just think about this. I know that tangent has 2 definitions. It's either y over x, if you're just thinking coordinates, or it's sine over cosine. In this quadrant, one is positive, one is negative. What's a positive over a negative or a negative over a positive? It doesn't matter. Negative. So tangent had better be what? Negative. Has to be. Okay. Down in quadrant 3 between pi and 3 pi halves. Is x positive? Is y positive? Okay, so there's nothing positive here. Except our attitudes. What's negative? Thanks for smiling. Sine. Ooh, maybe we'll change this here in a second. Sine is negative, right? Y's are negative, and x's are negative. I am going to change my mind. I don't think it's none anymore. How come? Why would tangent be positive there? Yeah, negative over a negative is going to spit out a positive. Cool. How about here? What's positive, sine or cosine? X is cosine. What's negative in quadrant 4? Sine. And if one is positive, one's negative, what do you think tangent's going to wind up being? It better be negative. Now, you may need this, like down in front of you to look at. You might not. If you can identify what ordered pairs look like in each of them, and just remember sine is y and cosine is x, all of this is just as easy as looking at ordered pairs x, y. Cool. Now, for the next problems, we get into a little weird area. I know that I'm trying to think of how to word this. You don't always love it when I say, check it out, here's a way to do the problem, here's another way to do the problem, here's another way to do the problem, because it makes it feel like you have too many choices. But here's the thing. With trig, there's always another way to do the problem. Now, I'm okay with seeing whichever one we walk through, and if you see a different way, might that be valuable to share with us? Like if you do a problem, we do it completely different, absolutely share it with everybody else. I won't make everybody learn it here, but we're going to knock this out. I want us to find and use theta prime, not just a big unit circle in front of us. I want to use our reference angle to find this. So I think there's A and B, I believe, but let's work through this one together, and if there's not a B, either we'll do another one together, or I'll just say do it on the homework and show me if you can do it or not. So right off the bat, when I'm trying to use reference angles to find a trig function, whether it's sine, cosine, tangent, doesn't matter. Always two-step process. Step 1 is I need to figure out where theta lives. And by that, I'm always going to word it that way, where does theta live? But I'm really just being lazy instead of saying, where does the terminal side of the angle theta live? Same question. 5 pi thirds is somewhere on your unit circle, or on a circle at least. It's some amount of rotation. How do you guys think about it? Like, talk with your neighbors, figure out which quadrant this is in. I've heard 2 and I've heard 3. I'm going to ask you to explain it, to logically go through it, and I'll show you how I logic through this. What do you think about it? Could you explain it? Okay, I agree with that. Okay, looking at this, thoughts? Which quadrant? Why? So I like, no shame on it. I'd like to know the actual logic behind it. Why 2? Okay, so second, I'll tell you it's not right. I wish I could hear your logic, and I'm sure there was logic, but if you're shy and don't want to share it, I get it. Check it out. How much is a full circle in radians? 2 pi. Now, unfortunately, we have over 3 right now, yeah? So I think in decimals very, very seldomly, but this is one of the few places where I do think in decimals. If it's over 3, it'd have to be 6 pi over 3, right? Which means 0.5, sorry, how do I want to word this? 3 pi thirds is half a circle, and I'm taking a different approach here. You guys agree with that? 3 pi thirds is pi radians, that'd be half a circle for you. Are we bigger than 3 pi thirds? Okay, so let's think about so just now we just covered the whole top half of our unit circle, from 0 to pi. Everybody cool with that? Okay, for the second half of the circle, on the bottom part of it, we're still just pi radians of rotation for the whole bottom half. Are you cool with that? Is that more than half of a pi? If you go, I'm trying to think of how, and somebody's going to guarantee I get what I'm saying, but it's a weird thing to explain. I know that 3 pi over 3 is half the circle. To get this, I have to add 2 pi thirds, right? Everybody cool with that? Now, in my head, here's what I'm thinking, though. Instead of that, I think about it like this. 2/3 of a circle. Is that, so that's 2/3 of half a circle, right? And the fractions get weird as we're talking about it. Am I more than halfway through a pi on that second part? So if I was here, and I got to think backward. So here's my first half, my full pi rotation. Then I go 2/3 of the way through another half rotation. Where did I just end up? I wound up in quadrant 4. Now, that's the decimal version. When I'm thinking about this, here's all that I think. I know that 2 pi is a lot. And I know that if I take it cut into fourths, each one is like pi halves. And I'm wrapping around logically here. Having a hard time finding my words. Let's play around with this. Let's work through this together. And then I'm going to reformulate that in a more clear, concise statement. Okay. So, I agree we're in quadrant 4. I'm good with that. And I guess I'm just going to make this note here. I'll even say it here because I think I have it. Forget about the pi on it. Do you guys agree that 5/3 is greater than, let's say, 0.75? Or even, we can even make it more than that. Gosh, is this getting too weird? Anybody understand what I'm trying to express here? Can you express it better than I am right now? Because I'm struggling.
Since you have 3 pi thirds, that's more than, that's half. Since you have 2/3, that's more than half.
2/3 of the rest of the half of circle. And that's what I'm trying to express, but writing it down winds up being more challenging than I was expecting. Because I think in decimals, but to justify the decimals requires me to talk a lot more. We'll get practice. Okay, quadrant 4. If you click through even, here's 3 pi thirds, 4 pi thirds, 5 pi thirds, 6 pi thirds. Here's 5 pi thirds. It's down there. Maybe that's an easier way to go about it. Cool. All right, so we're in quadrant 4. Now, the only thing that I care about this is automatically, I know that for this angle in quadrant 4, sine is what? Negative. Okay. Normally, I don't even write this down, or I'll just write a little minus sign next to it like you've seen me do before. But I know that my answer is going to be negative when I get to the end. So, there it is. I now need to find theta prime. And knowing that we're in quadrant 4, how do we find theta prime? 360 minus theta would be perfect if we had degrees. Just change it. 2 pi minus theta. Now, I'm going to take one step. I don't want to have to write 2 pi minus 5 pi thirds. I think that's ugly. Is it unreasonable to say we'll just jump right to saying 6 pi thirds? Why am I allowed to do this? What is this number? It's 2 pi, right? I'm just changing it to a fraction. Minus 5 pi thirds. What do we get for theta prime? Pi thirds. Okay. I now know that theta prime is pi thirds, and I know that we're in quadrant 4, so whatever I get is going to wind up being negative. When I write this out, I would not do this again, honestly, but I'm going to do it this one time. I know that based on what we have about reference angles, the relationship that we're seeing is that the sine of 5 pi thirds is really just, you said it was negative, right? Negative the sine of my reference angle, which was pi thirds. This kind of looks like that evenness and oddness, and it's certainly related. Have I lost anybody yet? Quadrant 4 means it's negative. Theta turns to theta prime, and now we've accounted for that negative part. So here's the big challenge. Don't look at your unit circle. Don't look at it. If you've already done it, just try to hold off. You don't even need to draw it. I'm just thinking this out on the board. Here's a unit circle. You tell me when I'm at a third of the way through the top half of my circle. Okay, is it here? No, that's like a sixth of the way through. So it's like really right up here. Okay, I know that that's a special angle. That is a very special angle. What I care about here is I know that there's x's and y's on the unit circle. The only one where they're the same is at 45 degrees or pi fourths. All I care about right there, is it higher up? Is it more in the vertical direction or more in the horizontal? Way more vertical. So it's something over 2 and something over 2, right? And we're focusing on this y value because it's sine. Well, if they're not the same, do you remember what possible numbers show up here? Root 1 and root 3, right? Which one's bigger? Root 3. I'm more up. There we go. That's that same idea that I used to memorize the unit circle. All of a sudden, we have our value. So let's just keep going. I know that this is negative, and we just determined that the y value at an angle of pi thirds, or the sine of pi thirds, was what? And the only thing that I'm going to change now, because it annoys me, this is annoying, just the way I've written it. But it's what I've done, right? The sine of pi thirds is here, and I just kept the negative. If you want to skip this step, I encourage it. It's just negative root 3 over 2. We're done. Easy peasy. Beautiful cover girl, I think. Doable, super hard. If you can find the quadrant and only remember one quadrant of your unit circle, you now only need ever one quadrant of your unit circle, because these reference angles will always be a quadrant 1 triangle as long as you fix the positives and negatives. Do we need to do another? Let's do one more. And I'm going to show a lazy amount of work. I want you guys to do this, and I'll show you. I'm going to give you a head start. I'm going to let you work through it, and then after you get a head start, I'll show you the amount of work that I would show. Cool. Do it to it. I want to explicitly see written somewhere on your work which quadrant and theta prime. I want you to find both those things. Now, there's a fun little curve on this problem that I want you guys to talk with one another about, but I'll have you get started. Well, what's so weird about this problem? This angle's strange. How come? It's more than a circle. Could you tell me how much more of a circle it is? Like, I know there's how many radians in a full circle? 2 pi. What if I wanted it over 6? Here's my 2 pi, right? 12 pi 6. Plus how much more? Now, Are my functions, trig functions specifically, are they periodic? Meaning, do they repeat themselves over and over? So if I'm here and I go another full circle, do I wind up here at the same spot again? Like that plus 2 pi doesn't change anything, right? Because I just end up at the same spot over and over. With that in mind, do I really need that? No, they're the same thing. It's that plus 1 full circle winds up at that same spot. So 17 pi 6, hard to think about. 5 pi 6, much easier to think about. Are we at a full pi yet? No, we're 5/6 of the way there. So if I try to go 5/6 around this circle, about there, which quadrant did I just end in? 2. This is a quadrant 2, which implies to me that tangent in quadrant 2, I know that x is negative and y is positive, and if they're opposite, this is negative. Boom, I got it. I know that it's going to be negative. Now, in reality, when people, I see you guys looking at your unit circles, and this is where it gets weird. Reference angles are valuable, especially when you don't have a full unit circle in front of you to deal with. Does 5 pi 6 show up on your unit circle? You bet it does. Is it possible that you don't have the entire circle memorized? If you don't have the entire circle memorized, which you might not, I think everybody demonstrated at one point at least you could build it, but I don't care about the whole circle. I only care about quadrant 1. Do you have quadrant 1 completely memorized still, do you think? Okay, that's all we need. If I want theta prime in quadrant 2, how would I find it? And I'm going to be honest, I switched to degrees in this thought process. If theta is 170, theta prime is 10. I know it has to be the case because they have to add up to 180, right? So 180 minus theta is how I get that reference angle. And I think that through every time. I don't memorize the little thing that we did yesterday. It's nice, and I use that logic over and over. I just don't memorize it. I'm not going to use 180 degrees. What am I going to use? Not 2 pi. What's the same as 180 degrees? Pi. And I'm going to write pi in a special way here. How would you suggest I write it? 6 pi 6 is pi, right? Minus 5 pi 6. Hey, theta prime is pi 6. So when I'm working out this question, I know that I'm really just evaluating the tangent of pi 6. And then because I was in quadrant 2, what am I going to stick on front of the answer? Louder, JV. A negative. That's it. If you know pi 6, you got it. So pi 6, I know is this very first spot on the unit circle. If we want to think about it, it's like there. If you have the unit circle in front of you, that's fine and dandy. You are welcome to use it. Can somebody tell me the ordered pair here without looking at your unit circle? How do you know that that's root 3 over 2? There. Further right than it is up. If that's how far it is to the right, what does it have to be up? 1/2, because this is always how they show up, right? Okay, so here we are. I have the x and the y, or the cosine and the sine, if you want to think in trig terms. So let's just do it. I know that the tangent of 17 pi 6, which is the original angle that we started with, turns out is just the negative of the reference angle. And we just decided it was pi 6, right? This negative only comes from that quadrant that we're in. Okay, if I take y over x to get my tangent, my negative hangs out. Let's do the y over x. And I'm going to skip a step here because I don't want to write a complex fraction. If I take the y, it's 1/2, right? Why did I write multiply instead of divide? I thought it was y over x. The reciprocal, right? Well, what am I going to multiply by? Love it. I'm just going to flip the x coordinate. Shuja. One more line and we're done. I know there's a negative. What do we get when we rationalize it? We're done. Piece of cake. Now, the weird part about this, if you have a full unit circle in front of you, are you ever really going to have to use reference angles? No. Like, realistically, But I'm going to feel like every math teacher ever for, like, the last 100 years. You're not always going to have a unit circle in your pocket, are you? That joke probably doesn't land with you guys, does it? Any idea what I'm referencing there? Probably not. You guys are too young. For years, growing up, you're never going to have a calculator in your pocket your whole adult life is what they used to tell us always. And now we have so much more than a calculator. All right. Everybody's laughing and pure. Good. Cool. Doable? All right. Uno más. We're going to use some identities too. Now, again, I don't love the idea of showing you a bunch of different ways, but I'm going to force half of the room, and it's not really half. Rafa, you're on this team over here. You don't have to move. I'm just going to say do this side of the room. Okay, for this, we have all this information given. We have an angle that's in quadrant 3. Cool. And I'm given the sine. I'm asking you guys to find the cosine and the tangent using trig identities somehow. Now, just to be super duper clear, there's no reference angle in this problem. We're doing a different type of problem at this point. So, do I tell you which trig identity to use? A trig identity is all I really reply, or that I give you, right? Okay, you do not have to show both of them unless you want to, but I'm going to make you guys, each half of the room, do this problem using a different identity and see that we get the exact same answer. So, here we go. Here's my dividing line. Just kidding. We'll do it there because that looks more like half. Okay. You guys over here and Rafa, I want you to use a Pythagorean identity. And I'm not going to say any more than that. I'm just going to say Pythag. You guys here are using a Pythagorean identity. Okay? You guys over here are going to use definitions with x and y. So we'll say sine equals y over r, cosine equals x over r, and tangent equals y over x. So these are just my definitions more than an identity, but it's true. Cool. Pythagorean theorem or identity of some sort, these definitions on the other side of the room. So you guys, definitions. Talk it out. We'll look at both of them. When I saw this problem up here, I think about it in the terms of the right side. That's the first stop that my mind makes because I know that sines, cosines, and radii are all represented there. Alternatively, and this is an everybody question, there are 3 versions of a Pythagorean identity that we looked at the other day. But there's only one that I really care about because the other ones come for free. What is the Pythagorean identity that I care about? Sine squared theta plus cos squared theta is always forever equal to what? 1. What did I give you guys before? Like I have to scroll up to see. We were given sine, right? Okay, so I have to think about quadrant 3 still, but let's check it out. -5/13 squared plus cos squared theta equals 1. Everybody on board with that? Is this what you guys did? What did you do just out of curiosity? Ah, I got me good. Sorry. Did you guys notice that as I was talking to you? Feel free to call me out on that. Did everybody do it that way then? Okay, do we all agree on that way? My bad. Cool. Do you agree that this is true and that this is what we were just told sine was? So I'm going to do a little bit of rearranging here. I'm going to square this. It becomes 25/69. And I'm going to subtract it to the other side. All in one step. So 1/69. Cosine squared theta then is equal to, it's 1 minus 25/69. And I'll write this out, but I'm going to erase it. 1 minus 25 over 169. And I lied. I'm not going to erase it. I'll just go one more line. Cos squared theta then is, gosh, I hate fractions. This is hard. Can you do 169 minus 25? So I think this is 144 over 169, right? And here's the big moment of truth. If I want to solve for cos theta, which is one of them that I needed. How do I undo that square? Okay, square root. Okay, I don't remember how I worded it. If I've already said it, sorry to be redundant. This is the real moment of truth, right here. Anytime you take a square root of a number, what goes in front of it? So check it out. You do not need to write this, but I'm going to be really obnoxious with it. I'm just going to call this 12/13 right off the bat. It's one of those. That's all I know at this point. How do we decide which? One more time. Oh my, quadrant? What quadrant are we in? In quadrant 3, should cosine be positive or negative? Okay, well, since I know that x's and therefore cosines, boom, we get it. We're done. Are either of these easier than the other? I don't know that answer. Is there a Pythagorean identity that if we wanted to find tangent, we could? So here's the cool thing. I don't remember it. I know there's a 1 and probably a tangent and either a secant or a cosecant, but I just don't recall. But looking at this, if I wanted this to become tangent, I would just divide this by cosine. So without having to remember it, I can work it out. I'm going to divide everything by cosine. That would become tangent squared. And this over cosine would just be 1. And this 1 here over cosine would be secant. Now, there's a little bit more work on this side of it because we don't know the secant yet, but I know that the secant is just 1 over the cosine, right? Which we also have already. We can use nothing but identities. Never take a look at our circle and solve this problem. As soon as we look at the second part, I think the right side of this is the easier approach. But they're both identities because they're just definitions and things that are true for any angle, and we can solve it. Cool. You already said what we're adding, but here's the other fun part. We are having a short quiz tomorrow. Okay, it's not going to be like an hour-long quiz. I'm going to try to make our quizzes more quiz-like instead of test-like, so I will make it shorter. Here's what we've covered so far. We talked about radians and degrees, how to convert. We discussed how to find an arc length, the area of a sector, and then linear and angular velocities. Change in position over change in time. It's just whether it's a part of a circle or not. Okay, beyond that, other things that I might draw from. Unit circle, SOHCAHTOA questions, and now our reference angles and any identities. For your cheat sheet tomorrow, I'm going to give you a little note card, but beyond that, if you look in the front of your book, I will have paper copies of this for you tomorrow. You do not have to put any identities on your cheat sheet. You do not have to put the unit circle on your cheat sheet. Pretty much only examples and definitions for stuff that's not physically written on this page. Cool, cool? Cool, cool, cool. All right, we get 12 minutes to work on the assignment or prep your note card. Baller.